My dear friends, welcome to Rajashekar classes on Applied Data Science with Python. This is lecture number 110. In this lecture, we will try to understand assessing normality. Another important thing is assessing normality. The normality assessment is very important for other type of information statistics. I will tell you why it is important because we will study a concept called central limit theorem. This theorem is very important. This central limit theorem I will discuss after completion of all the distributions. I will repeat. I will tell you why it is important because we will study a concept called central limit theorem where when you do the sampling of sampling, that will follow normal distribution. So many analytical tools and many statistical tools follows the assumption of central limit theorem, which will be discussed in future classes. That's why as soon as we collect the data, the first step is cleaning the data. In that process, you have to verify whether the data follows normal distribution or not. Otherwise, you may end up with using a wrong statistical technique or analytical technique. It is important to evaluate how well the data set is approximated by a normal distribution. Normally distributed data should approximate the theoretical normal distribution. The normal distribution is bell-shaped curve, that is symmetrical curve. The empirical rule applies to the normal distribution. What is empirical rule? 68, 95, 99.7 rule. I already discussed about this particular rule in my previous lectures. The interquartile range of a normal distribution is 1.33 standard deviation. What does it mean? If you calculate interquartile range IQR of given data set, it must be equal to 1.33 standard deviation. Means 1 sigma. We know how to calculate standard deviation. I already explained. We know how to calculate IQR. This relation between interquartile range and your IQR must be your interquartile range equal to 1.33 sigma. This sigma is standard deviation. If your data set follows this particular rule, I can say the data set fits into normal distribution. You can understand empirical rule also. I explained 68, 95, 99.7 rule. If your data set follows this particular rule, I can say it follows normal distribution. This bell-shaped curve, all those things we discussed a lot in my previous lecture. Just go through those lectures. Certainly you can understand it. Another way to assess the normality is construct charts or graphs. You can look at the shape of the distribution. For small or moderate sized data set, stem and leaf display and box and whisker plots look symmetric or not. If you look at stem and leaf plots, it should follow this kind of shape. This I already discussed what is stem and leaf plot. If you plot your stem and leaf plot, if you get this type of shape, I can say your data set is following normal distribution. In the box and whisker plot, for example, middle line, that is median line, should be at center for normal distribution, isn't it? Just where is that particular line? You know how to construct box and whisker plot. This must be at the center of this box. If this median is center of this box, I can say that data set is following normal distribution. Then we can say data set follows normal distribution. For a large data sets, does the histogram or polygon appear bell-shaped? If there is a large data set, just construct histogram. You know how to construct histogram in data visualization techniques for large data sets. Just construct histogram. Your histogram is something like this. I can say it is following normal distribution. Other way, compute descriptive summary measures. What is descriptive summary measures? Let me say, do the mean, median and mode have the similar values? If mean, median, mode have similar values, I can say it follows, data set follows normal distribution. Is the interquartile range approximately 1.33 standard deviation? That I already discussed this point, interquartile range. In initial slide only we were discussing that your interquartile range is 1.33 sigma. Sigma means standard deviation. Actually, I am repeating this point. Of course, if it follows this particular rule, I can say the data follows normal distribution, isn't it? Is the range is approximately 6 sigma. What is my range? If I calculate range, that must be equal to 6 sigma. What is my sigma? Sigma is standard deviation. If your range equal to 6 sigma, if your range equal to 6 into sigma, sigma means standard deviation, I can say that data set follows normal distribution. Even if your interquartile range equal to 1.33 sigma, in that case also I can say your given data set follows normal distribution. These are some descriptive measures to check whether the data follows normal distribution or not. You can find the skewness. If the skewness is 0, if you calculate skewness, I already discussed in previous lectures how to calculate skewness. If your skewness equal to 0, if the skewness is 0, then we can say this data follows normal distribution, isn't it? Just go through this. I can say like this. Some more examples to check the normality. Observe the distribution of the data set. Just observe the distribution of the data set. Do approximately 2/3 of the observations lie within the mean plus or minus 1 standard deviation. Just observe in your data set. If your 2/3 observations are within the range of mean plus or minus 1 standard deviation. Just check this rule. 1 standard deviation. Then I can say your data set follows normal distribution, isn't it? Do approximately 80% of the observations lie within mean, that is mu plus or minus 1.28 standard deviations. Then I can say standard deviations. Then also I can say the data set follows normal distribution. Do approximately 95% of the observations lie within mu plus or minus 2 standard deviations. 2 standard deviations. In that case, in this case also, I can say that your data set follows normal distribution. These are the few observations. Just check any one of them. If it follows any one of all these rules, I can say your data set follows normal distribution. These are different points I collected from different sources. If any of these properties, if your data set follows any of these properties, I can say your data set is normally distributed. This concept is very important. Once if you're sure about your data set, once if you have an idea that your data set is following normal distribution, we can apply different, you can view the data with in different dimensions. Anyway, I will discuss few more details about this particular normality while discussing problems in data science. Thank you very much.